In the past several lectures, we discussed the concept known as motional EMF, which is essentially the voltage difference induced inside a conducting wire as a result of a moving conductor within an external magnetic field. So this concept can be applied into medicine. So doctors and physicians essentially use emotional EMF to measure the rate of flow of blood within a blood vessel. So this concept is known as electromagnetic blood flow meter. So we use motional EMF to determine the velocity of our blood within our blood vessel. So once again, we can use the concept of motional induced EMF to determine the rate of blood flow inside vessels. So let's look at the following two steps that we must essentially take to create our electromagnetic blood flow meter. So we take our blood vessel and we place that blood vessel into a region that has an external magnetic field given by B. Now in this case, our blood is moving in this direction and our magnetic field points out of the board as shown by the following blue lines. So next, we essentially take two electrodes. We place one electrode on the top portion of our blood vessel and the other electrode we place on the bottom portion of our blood vessel. And we connect these electrodes via a conducting wire to a voltmeter. Now, notice that we're essentially taking a cross-section area of this diagram, and that's what we see in part B, in diagram B. Now, in this case, our magnetic field B points in the following general direction, and the blood is coming out of the board. Now, notice the diameter of the blood vessel is given by L. And notice our diameter L is perpendicular with respect to our magnetic field, which is also perpendicular with respect to our blood flow, which is coming out of the board. So, as our blood flows, blood contains different types of charged ions and charged particles. So that means the blood acts as if it was a moving conductor. When the blood flows, it essentially induces an EMF, a motional EMF inside our wire between these two electrodes. And that creates an induced electric current that flows through our voltmeter, and then we can use that voltmeter to measure our voltage. And then we use that voltage, as we'll see in this example, to calculate the velocity of the blood. So once again, we produce an external magnetic field in the region of our blood vessel. A connection is then made between the blood vessel and the voltmeter using these two electrodes. Now, in step 2, the blood contains many ions and charged particles. So when the blood flows along the vessel within a magnetic field, it acts as a moving conductor and it induces a motional EMF, which can be measured using our voltmeter. So once we measure that induced EMF, we can then calculate the velocity of our blood. So, let's look at the following example. In a certain blood vessel with a diameter of 2.5 millimeters, we place that into an external magnetic field of 1 × 10⁻³ teslas. And then the voltmeter reads an EMF, a motional induced EMF, of 1.6 × 10⁻⁶ volts. So we want to calculate the velocity of the blood. So we use the following equation, which we were able to derive in a previous lecture. So the motional induced EMF is equal to the product of the external magnetic field, the length, the distance between these two electrodes, which is simply the distance from one end of our blood vessel to the other, is our diameter given by L, multiplied by the velocity of the blood, which is what we're trying to find. So this quantity is calculated, it's measured using our voltmeter. This B is our magnetic field which we initially create, and this L is our length, it's our diameter of the blood vessel, which can also be measured. So we take this equation, rearrange it, and solve for the velocity. The velocity is equal to the motional induced EMF divided by B times L. Now our induced EMF is 1.6 times 10 to negative 6 volts as read by our voltmeter. Our B is given to be 1 times 10 to negative 3 Teslas, and our L is 0.0025 meters. So we divide this quantity by 1000 and we get 0.64 meters per second is the velocity, it's the speed of our blood within our blood vessel.